All right, Gus, you want to do this one? You want to speak for this video? You old fart? No? You want to look at the camera? All right, buddy. I guess I'll put you down, and I'll do the video from here. All right. Okay, so that's old man Gus hanging out with me during COVID-19. So let's in this video we'll kind of build upon what we were looking at prior, and we're going to pretend like we're compiling some C code, and we're going to look at what would the reasonable assembly language be from that compilation process. What would that look like? And we're going to focus on that. We're going to look at loops. Let's look at while loops and for loops in particular. This gives you an understanding of how things are running, right? How things are processing, and can actually also help you from a perspective of how long some given block of code takes to execute on a given piece of hardware by seeing how some block of code actually gets assembled or compiled into a sequence of assembly language instructions. So let's do while loops first. I think they're actually simpler than looking at for loops. So I think it makes sense as the one that we look at initially. And as part of that process, let's take it one step at a time, right? So we've got a comparison here. And actually, I might, oh yeah, we'll do it this way. So we got a comparison where we have register T0 is going to be compared against value 100. Okay. And then because this is a less than, we are going to do a branch greater than equal, okay, to determine if we're going to end the loop. Okay, so think about it is, what are we doing, right? We're comparing T0 to 100, okay? And if we're greater than or equal to 100, we're leaving the loop, right? We're leaving the loop, right? If it's less than 100, we want to enter the loop. Okay, the loop body. If we enter the loop body, well, what are we going to do here? Well, we're going to simply add. We're going to add T0 is equal to T0 plus 1. Doing pound 1, remember, is our immediate value. Okay. And then to kind of close the loop, right, we need to make sure that we can actually jump back, right? So after we do this, what happens in our normal C code, right? We hit this line. Well, what happens when we get to the end of the loop code block here? We come back up here and we check if this condition is true or false, right? So we should have an unconditional branch to some label that I'm going to call start loop up here. Okay, so well, what are we doing, right? When we get to after we add 1, we jump back up here, we compare T0 to 100 again, and we determine if that's greater than or equal to if it's greater than or equal to it. And if it is greater than or equal to, we're going to go to end loop, which we need to include down here. We need to define where that label should be. Okay. Now, if we trace this out, this is going to do the same functionality as our initial while loop on the left. Okay, that's what happens, right, when we take this and we compile it into assembly language. Okay. All right. Couple key things to just point out, right? Notice we have two labels. We have to indicate where the start of the loop is and the end of the loop is, right? Makes sense, right? Because we need to know when we hit after we run the loop body, we need to jump back up here and check the condition, okay? And if the condition's false, we need to know how to leave the loop completely, right? So that's why, you know, when you're doing the C code, you've got the similar thing happening there. It's just more concise and easier to read, okay? All right, it is important in this case that the comparison is occurring every time, because we are changing the value of T0 in the loop, right? So that comparison, the N and the Z bits can change, right? Based on, based on the new updated value of T0. Okay. So now let's look at what happens if we've got, if we were for a for loop, Okay, and I'm going to pretend, let's use R0 for I. Okay, let's use R0 for I. We're going to have something very similar. Okay, we have to indicate the start of the loop. Okay, we're going to have a comparison. Actually, let me back up a little bit just because we need to, I need to leave a little bit of room here. We do have some initialization that takes place, right? And if we want to think about it, we want to remember that this only occurs once, right? It occurs kind of as we're entering the loop. So logically, we want to have I set to 1. Okay, if I make a little comment here, okay, we want to set I equal to 1 prior to labeling that location. Okay, right? If we did it afterwards, we would continue resetting I to 1 every time through the loop. Okay, and that wouldn't really make any sense. It would not be the same logic as this. Okay, and likely be an infinite loop depending on what everything else was doing. Okay, so now we're ready for our comparison. We want to compare I, or R0, and we're going to compare it to 10. Okay. We want to compare the opposite of this expression here. Okay, so this is less than equal to, so we want greater than, right? We want branch greater than BGT, okay? And that will determine when we're going to end the loop. Okay. And then we have the loop body, right? I'm going to use, if we use R0 for I, I'm going to use R1 for sum. Okay. So we're going to say add R1, R1, R0. Okay. Now, in the previous example, after we did that, I immediately did an unconditional branch to start the loop. Okay. However, we're not ready to do that yet, right? We can't just jump back up to the start of the loop yet. Because what happens before we do this comparison is we add 1 to I, right? We need to make sure that we don't forget that adding 1 to I, right? I plus plus. Okay, this is pound symbol. If you can read that, that's pound 1. Okay, pound 1. Make that a little bit more legible. Okay. Once we've done that, now we're ready to jump back to the start of the loop. Okay, we don't want to forget that we also need to label the end of the loop. Okay. Right, so that's what happens, right, when we take a for loop and we compile it, right, into assembly language, right? Remember, we have to initialize, right? We designate when the start of the loop occurs, right? Remember, when the loop, every time it loops, we don't hit the initialization every time. We only do it once. Hence, that's why it's up here, right? We got our comparison. We've got our check of the current program status register. Remember, we're going to check the opposite of what it looks like when we're doing a higher level language such as C. Less than equal to becomes greater than. We've got the body of the loop here. We've got the increment I plus plus here, right? After we do the increment, we have the unconditional jump up here, right? Which is our checking of this condition. Okay. If the condition is, here, if it's true, it comes in, runs that. The body of the loop. Here, if the condition is false, it goes and runs the body. That's why we're doing the opposite condition. Okay, the opposite of the logic. Instead of less than, equal to, we're doing greater than. All right, so feel free to check that multiple times. It's good to practice it. We'll definitely have an opportunity to practice these things to let it sink in. And we're getting to the point where we can start really trying to write some programs and getting more of a feel of doing some more open-ended things in assembly.